Taking question number 15 of exercise 11.2 of three-dimensional geometry. The question is, find the shortest distance between the lines, and the lines given are x plus 1 upon 7 is equal to y plus 1 upon minus 6 is equal to z plus 1 upon 1 and x minus 3 upon 1 is equal to y minus 5 upon minus 2 is equal to z minus 7 upon 1. Okay. Now, because the lines are given to us in Cartesian form, so we are going to apply the formula which is for the Cartesian form. And first of all, we are going to calculate the value of a1, b1, c1, a2, b2, c2, that is comparing both the equation with the standard form. And we are going to calculate after this the value of x1, y1, z1 and a1, b1, c1, and similarly x2, y2, z2 and a2, b2, c2. Now both the equations are given in standard form. Okay, so a1, b1, c1 would be equal to 7 minus 6, 1, a2, b2, c2 would be equal to 1 minus 2, 1, and x1, y1, z1 would be equal to minus 1, minus 1, minus 1, and x2, y2, z2 would be equal to 3, 5 and 7. So it is very easy to calculate the value of x1, y1, z1, x2, y2, z2, a2, a1, b1, c1, a2, b2, c2. Okay, so we can write the values as like this. Okay, so the formula which is required to know is this, that the shortest distance between the two lines is given by the modulus of this determinant x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2 upon square root of b1, c2 minus b2, c1 whole square plus c1, a2 minus c2, a1 whole square plus a1, b2 minus a2, b1 whole square. Okay, so this formula is not very difficult to remember because you have to first of all only remember that in the first row we have the difference of the coordinates of the points which are going to lie on the line, on the respective lines, and a1, b1, c1 direction ratios of the first line, a2, b2, c2 the direction ratios of the second line, and the whole value is going to divide by b1, c2 minus b2, c1 whole square, and you have to just change b with c and c with a to get this expression, and c with a and a with b to get the next expression. So if you apply a little bit of tricks, then in your exams you will not get this formula wrong. Okay, now comes the solving part, and you must be knowing that if we are going to take all the values and place it in this formula just like this, then the calculation would become difficult to solve. So we are going to take the calculation in parts. First of all, we are going to solve this determinant. Okay, and we are going to place the value of all these x1s, x2s, a1s and a2s. Okay, all these values we are going to place. So we are going to get this as 3 minus minus 1, 5 minus minus 1, 7 minus minus 1. You can see we have taken the difference. We have placed the value of a1, b1, c1, okay, and a2, b2, c2. This can be written as equal to 4, 6 and 8, and next we are going to expand it. So this will be equal to 4 times minus 6 minus minus 2, minus 6 into 7 minus 1 and 8 into minus 14 minus minus 6. Okay, so this will give me you can see that this will be equal to inside the bracket 4, so minus 4 actually, so I'm going to get minus 16. This will be equal to 6, so minus 6 outside, so I'm going to get minus 36. This will be equal to plus minus 8, minus 8 into plus 8 would be equal to minus 64 or minus 116, right? Now we are going to calculate the value of this expression. So what we have to do, we have to just place the values. So this will be equal to minus 6 into 1 minus minus 2 into minus 1 whole square. You can see b1 as minus 6, c1 is equal to 1, b2 is equal to minus 2, and c2 is equal to 1. Okay, and similarly we are going to place the respective values of C1, A2, C2, A1, B1, A1, B2 and B2, A1 to get the expression like this. Further, we can write this value as equal to, you can see this will be equal to minus 6 plus 2 minus 4. This will be equal to 1 minus 7, that will be equal to minus 6. This will be equal to minus 14 plus 6, that will be equal to minus 8. So this will be equal to 16 plus 36 plus 64 as we have done here. So this will also be equal to square root of 116. Now we are going to place the value here. So this will be equal to modulus of minus 116 upon square root of 116, or simply square root of 116, which can be written as square root of 4 into 29 or 2 root 29, which is the required answer. So this is how we are going to solve this question.
Friends, thanks for watching my video. To watch more of these super videos and for the latest updates, subscribe and like the videos on these channels on YouTube, HSK Shiksha and Math Help by HSK. Thank you.